Hi guys, this is another emerald doubt. A disk of mass m lies flat on a smooth horizontal table. A light string runs halfway around it as shown in the figure. One end of the string is attached to a particle of mass m, so that's a mass m, and the other end is being pulled with a force F. There is no friction between the disk and the string. So safely we have the tension in the string all around same. Find acceleration at the end of the string to which force is being applied. So you have to find the acceleration of this part. Yeah, so pretty straightforward. You have the free body, the diagram, the force is made. You are pulling the string is pulling you, the string is pulling the disk, the string is wrapped around, so the other end also you have this pair of tension. So one T is pulling the mass m and the other end of the same string is pulling the disk. So if we write the F is equal to ma for the disk, then that's this. 2T are the two tensions which are pulling it, no other force. Mg is vertical, you have a normal reaction from the ground, this is the top view of the disk, so 2T is equal to mass into acceleration of the disk, call it as A2. So A2 will be with respect to the ground, right? We have taken the real forces. Similarly for the small mass, this point mass m, there is only one force which is T acting on it, so T is equal to ma1. This is again with respect to the ground. Now what is the acceleration of this end of the string? The string is tight all the time, so the pulley has moved say A2, so you'll get A2 and A2, you'll get 2A2 because this and this part extra string, and then this guy has gone A1 forward, so here also you'll have a loose string of A1 amount, so you'll have A1 plus 2A2 as loose string, so which you can again tighten it by pulling this. We are doing constraints over here, right? So you can just move, instead of A2 you move x2 amount of the pulley, instead of A1 you move x1 for the mass m, and just look at the figure how it will be. So it will be something what I have drawn, and hence your acceleration of the string on the other end will be A1 plus 2A2, which is putting these values over here, 4T plus T by m, and your T is nothing but the force with which you are pulling the string, so that with that force the string is pulling you back, so it is 5F by m as your answer. Thank you.